right, example 4 here. So this time, instead of making your own graph, you have to look at the graph, figure out what the transformations are, and then write the equation. There is a parent function up there for reference. So when I look at the graph, so I'm looking at this bottom blue graph here, I should first be able to tell that it's upside down, which means that this graph was reflected over the x-axis. Okay, so that is the first transformation that happened. The next thing I noticed is that you could say it went down 3. I noticed that it's down 3. And my graph looks wider. So I have to decide, is this a vertical change or a horizontal change? Now that we have two options, we have to look at the values. So think about your parent function pattern. Normally here on this top graph, I'll use a different color. You start at the origin and you go out 1, up 1. So if I start at the vertex here, this time I have to go out 3 to go up 1. Since I went out 3, that's changing the x, which means that that is a horizontal stretch. I'm going to abbreviate now because this is typically what we'll do in our notes if you're looking at the key. Horizontal stretch by 3. Okay, it's 3 times as wide. If I look at the next pattern, I went out 2, up 4 usually. This time I went out 6 to go up the 4. So that's out 3 times more than usual, right? 3 times more than 2. So here, to write the equation of y equals, I have to use the reflection over the x-axis first. Okay, that's a negative in front of everything. The next thing I have to take care of is the horizontal stretch. Now, a horizontal stretch goes inside the parentheses with the x. Remember, when you have a stretch, the horizontal stretches, which is the bottom guy here, make sure the number in there is the reciprocal of what you stretched by. So since I stretched by 3, the reciprocal of that is 1/3. Okay? And then I take care of the down 3 by putting a -3 on the end. Okay? That's example 4.